In this video, we're going to review some of the key content that we discussed in Chapter 3. So the first content that was discussed, or one of the first things that we talked about, was what slope tells you about an object and how we can relate it to something. So we know slope is vertical change over horizontal change. So in this first example, it says a ladder leans up against a wall at a slope of 4.5 feet per foot. The base of the ladder is 3 feet from the wall. How high up on the wall does the ladder reach? So to get an idea of how this would look, we have a ladder leaned up against some wall, and we know how far that ladder is from the wall. So the ladder is 3 feet from the wall. And what we want to determine, essentially, we want to determine this height. So if we know slope equals vertical change over horizontal change, and we know what our slope is, then we know 4.5 equals the height divided by 3. So now we want to solve this equation for h. I could think of 4.5 as basically being over 1. And if we cross multiply that, 1 times h is h. And 4.5 times 3 is 13.5. And we know that height, since it's feet per foot, this must be 13.5 feet. Example 2. A ramp up to an entryway into a garage has a slope of 0.8 feet per foot. The entryway is 10 feet above the ground. How far is the ramp end from the base of the entryway? So a similar idea here, but we don't have quite as steep of a slope. We're going to have something similarly shaped, but here is our entryway. And we know that the entryway is 10 feet above ground. The question now is, how far is the base away? So in this example, we're looking to find, and let's call this, we can use h for horizontal change, I guess. So here we're trying to solve 0.8 equals our vertical change over our horizontal change. There's a little bit more algebra to do here. 0.8 times h, that's 0.8h, and 1 times 10 is 10. So h is going to be 10 divided by 0.8. Which will be 12.5 feet. In other words, the horizontal distance away will be 12.5 feet from the entryway. When considering parallel and perpendicular lines, what makes two lines parallel is that they have the same slope. When considering perpendicular lines, what makes them perpendicular is that they have negative reciprocals. So in this example, we want to determine if a line through each of the given points is parallel, perpendicular, or neither to a line through these 2 points, -5, 2, and 3, 34. So in order to do this, we want to first compute the slope between these 2 points so we can compare it to our other lines. We know slope is y2 minus y1 over x2 minus x1. So for these two particular points, 34 minus 2 over 3 minus -5. 34 minus 2 would be 32. 3 minus -5 would be 8. So in this case, we have a slope of 4. So we want to compare to 4 and see what these other lines do. In A, if I was to compute this slope, 37 minus negative 11 over 5 minus negative 7 is 48 over 12, which equals 4. So this line would be parallel. In this second example, m would equal 7 minus 9 over 9 minus 1. That's negative 2 over positive 8, and that will reduce to negative 1/4. That is a negative reciprocal of 4. Since 4 is really 4 over 1, we would say this is a perpendicular line. Alright, and now we're going to take a step further now that we understand slope and how it relates to parallel and perpendicular lines. And we're going to actually start writing some equations of lines. So we know we want to try and write some y equals mx plus b. And if we let y equal f of x, we could essentially say this is the same thing as f of x equals mx plus b. So we want to write a linear equation for the function through the points negative 6, f of negative 6 equals 1, and f of 3 equals 7. That's essentially the same thing as the points negative 6, 1, and 3, 7. We also previously discussed point slope form. And what we can do is use this point slope form and eventually convert it into slope intercept form. So let's start first by finding m, our slope. So m would equal 7 minus 1 over 3 minus negative 6. 7 minus 1 is 6. 3 minus negative 6 is 9. And we know 6 over 9 reduces to 2/3. So now we have a slope. And we can pick either one of these points to create our point slope form. So I would pick 3, 7 just because those are both positive numbers and it makes it easier to work with. So y minus y1 is 7 equals our slope 2/3 times x minus 3. Now we want to convert this to slope-intercept form. So the first thing I would do is distribute in this 2/3. Y minus 7 equals 2/3 x. And then 2/3 times 3 would be the same thing as 6 divided by 3 is negative 2. So we have y minus 7 equals 2/3 x minus 2. And if I add 7 over to get a y equals equation, y equals 2/3 x plus 5. And the only thing we want to do now is substitute f of x for y. So it's really f of x equals 2/3 x plus 5. Now using our idea of parallel and perpendicular lines, in part B we want to write the equation for a linear function that's parallel to the function we found in part A, but we're going to write this as y equals mx plus b. So if we're going to write a parallel function, we know it has the same slope as our original function, and the original one was 2/3. And I'm going to use the point 6, negative 2 as my x1 and my y1. So using point slope form, this would be y minus negative 2 equals 2/3 x minus 6. We know y minus negative 2, That's actually a y plus 2. We distribute 2/3. 2/3 x. And then 2 over 3 times negative 6 is negative 4. If I subtract 2 over, we get y equals 2 over 3x minus 6. Now we want to write an equation that's perpendicular, but through 4, 1. So if it's perpendicular, our slope is going to be a negative reciprocal. So if the original was 2/3, the perpendicular would be negative 3 over 2. Using the point 4, 1, we can write point slope form. So y minus 1 equals negative 3 over 2, x minus 4. Y minus 1 would equal, if we distribute that in, negative 3 over 2x plus 6. And adding 1 over, y equals negative 3 over 2x plus 7. In this example, we're going to look at what it is that makes something a linear function and how we can identify and be certain that it is. So here we're going to let I be the number of insects in a population in thousands, W weeks after treatment was administered to reduce the population. Show that the data for the number of insects can be modeled with a linear function. So what we're really looking to show here is that the slope is the same throughout this function. So we want to look at the change in the dependent variables over the change in the independent variables, or the change in outputs over the change in inputs. So starting with the 0 to 3 week range, we would look at 13.9 minus 17.5 over 3 minus 0. And if we compute that value, we'll get negative 1.2. Continuing on, if I look at the 3 to 6 week range, 10.3 minus 13.9 over 6.3, and again we get negative 1.2. And looking at our last space or range of values, 6.7 minus 10.3 over 9 minus 6, again we get negative 1.2. So what we've shown is that we have the same slope throughout this function, so we would assume that this is a linear function. What is the slope for this particular model, and what does it tell you about the population? Well, the slope here is negative 1.2. What that tells us is every time the input goes up by 1, which in this case is weeks, so for each additional week, the slope tells us the change in the output. Well, if it's negative 1.2, that means the population is decreasing by 1.2 thousand each week. So for each additional week, the population decreases by 1.2 thousand insects. If we were to be getting a positive slope, then that would mean that the population was actually increasing, but since it's negative, we know it's decreasing. Write a function that can be used to model this situation. So we know I is our output, and a linear function is the slope times the input, in this case negative 1.2. So negative 1.2 W, and then plus the initial value. The initial value corresponds to when the input is 0. So at 0 weeks, we have 17.5 thousand. So negative 1.2 W plus 17.5. How many insects do we expect to be in the population after 11 weeks? So in other words, we're inputting 11 for W. So I of 11 equals negative 1.2 times 11 plus 17.5. That gives us 4.3. And we know that this particular number, the number of insects, is in thousands. So we would suspect 4.3 thousand insects. In this last example, we're going to look at systems of equations and how we can use them to help us solve a word problem. So in this example, it says 500 tickets were sold for a certain music concert. The tickets for the adults and children sold for $7.50 and $4 respectively. And the total for the performance was $3,312.50. How many of each kind of ticket were sold? So I'm going to let A be adults and C be children. And we're going to try and create a system of equations out of this. The first fact I know is that 500 tickets were sold for a certain music concert. So if I'm letting A be my adult tickets and C be my children tickets, then I know A plus C must equal 500. And if I know $7.50 and $4 for those tickets, then $7.50 times the number of adult tickets plus $4 times the number of children tickets should equal $3,112.50. So I've created my system of equations. The easiest thing to do would be to eliminate one of these variables so that we can solve this system. I would say, to me, it looks easier to eliminate this C variable because all I would need to do to eliminate the C variable is multiply the top line by negative 4. So if I multiply the top line by negative 4, I get negative 4A minus 4C equals negative 2,000. And it's important that we multiply everything through by negative 4. My bottom line I'm not going to change because I wanted that negative 4 to cancel out positive 4. So 7.50A plus 4C equals $3,312.50. Adding those two lines, we get 3.50A equals, our C's will cancel. And when we combine this negative 2,000 and the 3,312.50, we get $1,312.50. So to solve for A, we're going to divide by our 350. So that tells us A equals 375. So we know that the adults, we had 375 tickets sold. So if we know how many adult tickets were sold, we can now find the number of child tickets sold, because 375 plus C should equal 500. So C equals 125. So that means the children purchased a total of 125 tickets.